Hi, welcome. So let's see typecasting in Java. Okay, it's an important topic regarding interview. Fine. Now there will be only three questions in your head. What is typecasting? Why we are doing typecasting, obviously, and how we are going to do typecasting. Okay, so in Java there are eight data types, eight primitive data types. Fine. What they are? Byte, short, char, int, long, float, and double and boolean. Okay, byte can store 1 byte of data. That means 8 bits. That means from minus 128 to plus 127. Okay, now you will be asking me how this value come from, like from where this value came. Minus 128 to 127, we don't know. See, just stay with me. I'll show you. I'll also prove that how this minus 128 came, how plus 127 came, and why this plus 127 not plus 128. What are the total values? I'll show completely for byte. Your job is to do same thing for other data types. Just stay with me. For now, just remember, byte can store 1 byte of data, and 1 byte equal 8 bits. What is bits? Binary number 1 2 3 4 5 6 7 8 bits. Okay, short can store 2 bytes. Char can also store 2 bytes. Int 2 byte. Long int 4 byte. Okay, 4. Long can store 8 bytes. Float 4 byte. Double can store 8 byte, and boolean can store 1 byte. Okay, true false, true or false, 0 or 1. Fine, this is clear. Fine, this is clear. Okay. Okay, now still the three questions is still there. What is typecasting? Why and how? See, what is typecasting? Typecasting means a type conversion. We will convert the data of one type to another type. Now the next question, why and how? Okay, so I'm going to tell you how first, and then this is my third question at the last. First, let me show you the chart flow where it's a crystal clear that okay, so these all data types required explicit. Definitely. Just see how I represent the data types. Byte, short, okay, int, char, long, float, double. If you observe carefully, from left to right, size increases. See here, 1 byte according to this chart. 1 byte, short 2 byte, char also 2 byte, 4 byte, 8 byte, 4 byte, 8 byte. Okay, I know 8 is decreasing in this case, long to float, but wait, I have a solution for this also. Fine. So generally it is increases 1 2 2 4 8 4 8. Okay, generally it is increases. Fine. Now the question is how these data types undergo typecasting. See, suppose I have created a variable using byte data type. Byte b equals 2. Fine. Okay. Now I created a variable using short data type. Okay, and I'm storing this b into it. What is the answer? What will be the answer? If I print this s, will there be any error? No. Why? Because see, there's a simple fundamental. Those who are coming on the right side, okay, in that data type, they can store the left side data type values. That means short can easily store byte, and that is we call as implicit type casting. There is no requirement of explicitly adding the efforts or explicitly adding some extra code. Why? Because the data type which is coming, which is there on the right side of this chart, they can store the left side data type values. Like I have created short, so short can store byte simply. Okay, suppose I create, this is the first example. Suppose I create char c equals a. Okay, and then int I equals c. Yes, it can execute it with no error. Why? Because see, int is coming here. It can store all the data of type byte, short, and char. Now you'll be asking, okay, byte short I can consider. How char is storing in int? I'll tell you why. This is an implicit typecasting. See, Java will see internally, okay, this int is coming on the right side. It can store char, short, and byte. Okay, so let's do implicit typecasting. Fine. So when it encounters char, it converts it into integer value. That means 97. How it comes? There's a Unicode values of all the characters. There's a Unicode table. That means character equivalent to integer value. Character equivalent to integer value. That is why we have put char to int. Direct connection. Fine. That is why char is a primitive data type. Get my point? Because char can be implicitly converted into integer value. Okay, the next example is, suppose I've created, okay, suppose I've created short s equals 3 and long l equal s. So is it? Yes. Why? Because see, in case of long is here. It can store all the values of type int, short, char, and byte. Means suppose the data type is at here, so it can store all the types, all the values of type before on the left side. In a point, this is what all about the scenarios. Now you will be asking me, okay, show me in code. Show us to code, like code this, all this theory. Fine. So let's open my Eclipse. Okay, so here's my Eclipse. Okay, now suppose I have created, see, first let me draw that chart here also. Okay, so byte, short, int, char, okay, long, float, and double. Okay, now first let me create int I equals 10, and then long, l equals I. See, there's no error. Let me zoom it. See, there's no error. Long is here. It can store all the values of these types easily. Int, char, s, or short or byte. Next example, let's see. Suppose byte, okay, and short. See here, no error. Fine. So this is what implicit typecasting. Let me take long I equals 10 and float. You can see there is no error. Fine. Why? Because you can see float is on the left side, right side. It can store all the types directly. It can implicitly casted all the types of the left side data types. Left side. Your point. So this is what the implicit typecasting. Fine. Now let me show you the explicit typecasting. So this is what implicit. Okay, the next thing is, so let me take this to the next page. Okay, fine. See, if I create suppose int I equals 10, okay, and then I'm storing it in a short s equals I, and suppose I'm printing system out dot print s. What will be the output? What would be the output? 10, 0, no output, or error? If your answer are one of these, then you are wrong. Compile time error. Why? See here. Once we write this line, short s equal I, compiler comes here and then checks. I is of integer type. Okay. And then compiler checks this chart, its own chart. Fine. And then checks, okay, it is an int data type and storing in which data type, because int can only be stored in these all. Fine. But we are storing in the left side, so it is not possible. It is not possible. Fine. What I told you, that right side data type, in the right side data type, left side values data type can be stored. Okay, but we are storing in short, we are storing the in data type. Reverse we are storing. It is not possible. Okay, but we have to store it. So this is what we known as explicit typecasting. Explicitly we need to tell to the compiler that yeah, we know it is in data type, but we want to store it in a short data type. So that's why how to do it. Short s equals I and short. Right here the data type name. This is the correct answer. Let's see in a code. Fine. So this is what the first thing. Suppose I have created, let us store, okay, the same example we've taken. Int I equals 10. Okay, short s equals I. See this, the error came, type mismatch, cannot convert from int to short. That's why we need to explicitly short. Now error gone. Okay, so this is what we know. This is the same thing for all the things. Like suppose I've taken float, float, float. I'm storing it into long. Same error, type mismatch. You can see because float is on the right side, can't store implicitly to the all the left side. Okay, but we need to explicitly told it. That's why it is known as explicit typecasting. That is why long. Now it's gone. Fine. So this is what the explicit typecasting. Okay, this is what explicit typecasting. Okay, and this is implicit. Now the very most important thing, what I promised you, that how it is done. Okay, what I told you. Now why is remaining before it let me show you how this is done, because my promise. Okay, now let me show you the most interesting thing, that is how this value come from. Like okay, one byte can store one byte, that is 8 bits that we have, but how this range come from. Okay, so let me show you. And yeah, I'm only doing for byte. Your job is to do for all the things, all the other data types. Okay, and then we'll see why. Fine. So let me show you. Okay, it's very interesting. Okay, so byte can store 1 byte of data. That means 8 bits that we have. What is bits? This binary. Okay, now in 8 bits form, what is the minimum value in binary? 1 2 3 4 5 6 7 8. It is a minimum value. Now you will be asking me why you haven't put here also 0. See, this is the signed bit. It shows the value is negative or positive. The minimum value is negative. Okay, on rest all are the value bits. Okay, fine. Now calculate the equivalent decimal value of this binary number. How to calculate? See, the next video is maths for DSA. Okay, in that I'll completely show from scratch decimal to binary, octal to a, and the beautiful tricks. Fine, it's of 2-hour video, but this is just a basic. Okay, because I just wanna show you like typecasting. So yeah, fine. Value into 2 raised to the power 0. Value into 2 raised to the power 1. Similarly, 2 raised to the power 2, 3, 4. So 2 raised to the power, see, all are 0 only because values are zeros. So 0 multiplied by 0, 0. Okay, and 2 raised to the power 0, that is 1. 2 raised to the power 1, that is 2. 2 raised to the power here it's 2, that is 4. 8, 16, 32, 64, 128. Get a point? Okay, see here how we calculate the value. Value is 0. Value is 0, right? Into 2 raised to the power 0. Why 2? Because base 2. Binary is base 2. Plus value 0 into 2 raised to the power 1 plus value 0 into 2 raised to the power 2. So 2 raised to the power 0 is 1. 2 raised to the power 1 is 2. 2 raised to the power 2 is 2 square 4. And these are multiplied by 0. So all these sum are 0 only. This plus this plus this plus this plus this plus. Because 1 into 0, 2 into 0, 4 into 0, so 0, 0, 0 plus 128. Because 128 into 1 is 128. And this is a signed bit. That means negative. So this is the minus 128. Digested? Okay. Similarly, what is the maximum value? What is the maximum value in 8-bit form? That is 1, 1, 1, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7 and 0. Now you'll be asking why you have put 0 here. Signed bit, maximum value is positive. Positive is indicated by 0. That's why here 0 and all are 101. This is the maximum value. Calculate this. 1 into 2 raised to the power 0 plus 1 into 2 raised to the power 1 plus 1 into 2 raised to the power 2 plus 1 into 2 raised to the power 3. Okay, similarly 1 into 1 into 1 into. This is the 1 plus 2 plus 4 plus 8 plus 1 into 2 raised to the power 4, 16 plus 1 into 2 raised to the power 5, 32 plus 1 into 2 raised to the power 6, that is 64. Add this all. 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. 6, 12, 20, 24, 24 and 3, 27, 2, 6, 8, 8 plus 3, 11, 12, 127. Maximum value. So the range become minus 120, minus 128, right? Because we got minus 128. That is a minimum value. Okay, so the range become range of byte is minus 128 to plus 127. Similarly, do it for short 2 bytes, 16 bit. Okay, short 2 bytes, 16 bit. Fine. So that is all. For this. Okay, so I've showed you how we got minus 128 to 127 range. Byte never, see, I'll show you. Suppose I store byte d equals, suppose 129. See here, cannot convert from int to byte because byte can store maximum to 127. It reaches, it goes out of the byte range. Now it reaches to by default. By default is int. By default int. See here, suppose I write here 120. No error. Minus 120, minus 130, minus 130. See, but minus 125. No error. They have some specific range. Okay, and this completely thing, this complete overview, the complete bomb of data types and octal, hexadecimal, okay, and then binary. So conversion of these and all these things, like how to get, okay, in our next video or the coming videos, I'll completely explore this. Fine. So this is what all about the video, and I hope you got a time. Yeah, so there's one more thing. Why we required typecasting? See, suppose in some of the methods it is explicitly given that you need to store the data in this type of data type. Suppose there is a method abc, okay, and it is only taking the short type of data type, the short type of value, a value which is of type short, of type char. Then that's why you need a typecasting. Other thing is memory management and memory efficiency, that you can store the int type of data into a short or byte. Definitely there will be memory efficiency. Okay, so this is what all about why, but the important thing is how and what. And the most important thing is this chart. Never forget this. Right, left. Right can store implicitly left, but for left we require explicit. Need to tell explicitly to the compiler. Yeah. Point. This is all about the typecasting video. Okay, so hope you like the video. If you like, then please comment down and subscribe. Thank you.